Thevenin's theorem, it states that any two terminal of a network can be replaced by an equivalent voltage source and an equivalent series resistance. Through this Thevenin theorem, we can reduce the circuit in terms of voltage source and the series resistance, or it will also be helpful for finding the current through any resistance or a voltage across any resistance. So all the network across or in series with the load resistance, we are replacing it with the voltage source in series with the resistance. We are calling it as a Thevenin voltage and the Thevenin resistance. For finding the Thevenin voltage, we are replacing the load resistance through which we have to find the current between A and B terminal. So we are replacing RL with the VTH and finding the VTH across terminal A and B. And for finding the RTH, we are also again same replacing the load resistance RL and finding the RTH in between the two terminals A and B. But for finding the RTH, we have to replace all the voltage and the current sources by their internal resistances. As we know, the voltage source having the internal resistance is 0, so we are replacing it with short circuit, and current source having infinite resistance, so we are replacing it with open circuit. Now we will see the steps for Thevenin's theorem or solving the problems related to the Thevenin's theorem. The first step is remove the load resistance RL, find the as you have seen here, when you are replacing the circuit with the VTH, RTH and the RL, so both of them are in series. So for finding the IL, we are applying the Ohm's law here. See here, only one voltage source is there, VTH, so IL is equal to VTH. IL, that means the current flowing through the load resistance. It is VTH divided by RTH plus RL, because RTH and the RL is in series. So for finding the IL, we are using VTH upon RTH plus RL, this formula at the end of the problem. Now the steps: remove the load resistance RL. Firstly, we are removing the load resistance through which we have to find the current. Then find the open circuit voltage VTH across the terminal A and B. As you have seen here, we are replacing the load resistance with the terminal A and B and finding here the VTH. This is the second step. Third step is we are replacing the terminal A and B with the RTH, or removing the load resistance RL and finding their RTH by replacing voltage source and the current source by their internal resistances. Next step is replace the network by a voltage source VTH in series with the resistance RTH. As you have seen in the introduction, we are replacing the VTH and the RTH in series with the load resistance. Then the last step is find the current through the RL using the Ohm's law. So for finding the current through a load resistance, we are using this formula: IL is equal to VTH upon RTH plus RL. See here, IL is equal to VTH upon RTH plus RL. Now we will see the problem based on the Thevenin's theorem. Just remember all steps. We are going stepwise. Now we have to find here find the current through the 2 ohm resistor. That means we have to find the current through this 2 ohm resistor, and we know through which we have to find the current. We are considering it is a load resistor, or it is RL. Now the first step is calculation of VTH. For finding the VTH, we are replacing the load resistor with the terminal A and B. All other circuits as it is. We are replacing only load resistor with the VTH. Suppose I am finding here VTH by removing the load resistance 2 ohm. We are removing the load resistor. Suppose terminal A is plus and the terminal B is minus. Now see here, the terminal A and B are open circuited, so there is no current flowing through this loop, only current flowing through this loop. Now we are finding the current through this loop. It will be easier to identify the VTH or solve the VTH equation for the VTH. Now the current flowing through the first loop is I. As we know, by solving the equations of the KVL, we are applying the sign conventions according to the direction of the current. Here we are considering the direction of the current is clockwise. So simply through the 5 ohm resistor, current flowing from this terminal to this terminal. So starting terminal is plus, end terminal is minus. Same here, the current flowing like this. So starting terminal is plus, end terminal is minus. Here the voltage source is 20 volt. Now we are applying KVL in loop 1. See here, suppose I am starting from the 40 volt source, current flowing like this, minus to the plus, so simply it's plus 40 volt, minus to plus, therefore rise in voltage we are considering the plus 40. Then for the 5 ohm resistor, it is from plus to minus, so it is fall in potential, and I am considering it is negative, so simply minus 5, and the current flowing through it is I. Then through the 20 volt source, it is plus to minus, again it is fall in potential, so simply it is minus 20. Through 10 ohm, it is plus to minus, so simply it is minus 10, and the current flowing through it is I is equal to 0. By solving this, we get the value of I is 1.33 ampere. Now the second step is we are applying KVL in the VTH loop. Applying KVL in VTH loop. See here, there is no current flowing through this loop, but through 10 ohm resistor the current I is flowing. So for this loop we are not considering any sign conventions. We are using the sign convention of the previous loop. Now suppose I am starting from the VTH, my direction which I consider for applying the loop, it is clockwise, so it is plus to minus, so I am considering it minus VTH. For the 10 ohm it is minus to plus, so simply it is plus 10. Then for the 10 ohm resistor we are using the previous sign conventions, so our considered direction of the loop is minus to plus, so simply it is plus 10 into current flowing through the 10 ohm resistor is I only, so I am considering here I is equal to 0. By putting the value of I is equal to 1.33, we get the value of VTH is equal to 23.33 volt. This is the value of VTH. Now the second step 2, is calculation of RTH. Now the same procedure for finding the RTH is we are replacing all the voltage and the current sources by their internal resistances. In this question there is no any current source, so simply we are replacing this 40 volt source and the 10 volt source by their internal resistance, and the internal resistance of the voltage source is 0, so simply it is short circuited. So the 40 volt source is short circuited. Then this is 5 ohm resistor, again the 20 volt source is short circuited. Then 10 ohm resistor, here the terminal A and terminal B is replaced, or in between we are finding the RTH. See here the 10 ohm resistor, it is short circuited again, so only the two resistances are in the circuit, and 5 ohm and the 10 ohm are in parallel, so simply RTH is equal to 5 parallel with 10 is equal to, we get it is 3.33 ohm. So RTH is equal to 3.33 ohm. Now we get the VTH and the RTH both. We are replacing this VTH RTH with the Thevenin's network. Simply we know the Thevenin's network is like this. Thevenin voltage is in series with Thevenin resistance, it is RTH, VTH, and then it is in series with the load resistance. We know the value of VTH is 23.33 volt. RTH is equal to, what is the value of RTH? It is 3.33 ohm. So simply it is RTH is equal to 3.33 ohm, and RL is equal to, it is 2 ohm. RL is 2 ohm, and we have to find the current through this load resistor. And we know the last step for finding the current through the load resistor is apply the Ohm's law in the loop. So IL is equal to VTH upon RTH plus RL. So simply IL is equal to VTH upon RTH plus RL. So we have, by putting the values, all values, we get RTH is, it is 3.33 plus 2. So simply IL is equal to 4.38 ampere. This is the final answer. Thank you.